Hello, everyone. It is 10 o'clock, so we are going to go ahead and get started. I wanted to thank you all for joining us. The topic for today's webinar is defending your cloud apps with Micronaut security features. Your presenter today is Sergio, and Sergio is a member of the Micronaut and Grails team here at OCI. So thank you again for attending, and with that, I will turn it over to Sergio.
Hello, everyone. Welcome to Micronaut Security Webinar. My name is Sergio del Amo. I am based in Guadalajara, Spain. Guadalajara is a small city in Spain with the same name as the Mexico City, which is really big, so don't be confused. Really close to Madrid. I am a member of, as Jen said, of the Micronaut and Grails team. I happen to write a newsletter about Micronaut, Grails, Gradle, Groovy, microservices named GroovyCalamari.com. It's a free weekly newsletter. There is a podcast in similar topics. I organized this year a conference named Gridge, which will take place the 28th of March, so next week. 28, 29, and 30. There are a lot of Micronaut content in the conference. So if you are in Europe or you are not afraid of taking a flight and crossing the ocean, the conference tickets are still available. So feel free to visit the website and discover the conference a little bit more. I am in Twitter at S del Amo. My website is sergiodelamo.es. Today I'm going to talk about security. There are a lot of topics around security in Micronaut, so I'm going to try to give an overview of options that are available. We are planning a workshop I believe next month, which will cover security with more detail, with more examples. But hopefully today you at least understand what options are at your disposal. So the first, I'm going to try to show with an example. So this will be a controller in Micronaut, and controllers in Micronaut are annotated with @controller. So this controller exposes an endpoint also, which is the method annotated with @get. So when you reach the URL /books, a list of books will be returned. Micronaut by default works with JSON, so the default media type will be JSON. So the output of the controller will be a JSON array of books, as you can expect. When you have this controller in Micronaut by default and you start your application, if you are using Gradle with run, run, and you host 88/books, you will get output. But we want to secure our app. So the first thing that we are going to do is we are going to install the security dependencies. I'm going to show how to install the security dependencies in a Gradle application. So Micronaut is build agnostic, so you can use either Gradle or Maven. There is not much to the change that you will need to use the Maven one. The samples that I have here are using Gradle, but if anyone has problems, please reach out to me and I will point you to the resources to install the necessary Maven dependencies. There are a couple of dependencies that you will install. Typically, you will have a compile dependency to Micronaut security, and then you will have a dependency in the annotation processor, which is the same one. And the reason why you will have that one is because Micronaut supports some annotations such as permit all or roles allowed. We will see that later. And those are possible thanks to Micronaut annotation mapper. So you will need both dependencies on your application. The next step after you have added those dependencies in your applications is to turn on security. So you turn on security in a Micronaut application by Micronaut supports configuration in YAML files, properties files, or even Groovy files. By default, you will get an application.yaml file under source main resources. So to turn on security is as easy as setting the enabled Boolean flag to true. And once you have done that, your app is secure by default. So if you try to hit the endpoint books, you will get a 401. So everything is secure by default in the moment you turn on security. So how does this happen? Micronaut uses a filter, which I'm going to try to make sense of it for you to basically evaluate if a request should be allowed to proceed or not. When a request comes, Micronaut goes through the list of authentication features beans that there are registers in the application context. By default, if you are using session, you will have a session authentication feature as well. If you are not using session, by default, you will have a token authentication feature. You can even add your own authentication feature. So these are beans, so you can always add another bean to the process. So the token authentication feature, which is probably the one that you are going to deal more often with, the first thing that it does is it calls another bean called the token resolver, which attempts to read a token. So a token can be, if you are using basic auth that we are going to see later, for basic auth will be something like the user with a semicolon and the password base64 encoded. If you are using and the token reader will attempt to read that from the authorization header. If you are using JWT authentication, you may send the JWT in the authorization header with a bearer prefix. So there is a token reader that will read that. But if you are using like a custom solution, you may choose to read the token from a request parameter or from a custom HTTP header. And you can do that with Micronaut. You just will need to register your own token reader. Once the app is able to read a token, it will attempt to validate that token. So there are authentication methods where the token is self-contained, such as JWT can be. So in those cases, the token validator may not need to collaborate with any other entities, may be able to validate the token. There are other chances where, for example, you will need to read the token, to validate the token, you will need basically to fetch a user from the database, check that the password matches with the password supply, and then consider the user authenticated. So there are a couple of ways to validate a token. Micronaut comes with many beans, which will be useful in most common situations. So you may not need to create your own token validator, but if you need, that's completely possible. If everything went well and you were able to basically read a token and validate a token, then an authentication object will be created, which basically identifies the authenticated user. And then at this point, we will know if the user is authenticated or not. It may be that the user is an anonymous user, and we may want to still let the user go through because the endpoint he is visiting, we consider it accessible for anonymous users. So we have another concept called security rules. And there are several beans which implement the security rule interface. One of them, for example, evaluates the annotation @secure that we will see. There is another one which evaluates a list of intercept URL map. We will see an example of that. There is another one that I believe I have not covered in this presentation, which evaluates the IP address originating the request. So you can basically only allow certain kinds of you can have like a wide list of IP addresses, and if the request is not coming from those, return a 401. So if at any point the security rule evaluation decides to reject a request, then a rejection handler will be used. Again, Micronaut ships with several rejection handler beans. If you are not satisfied with any of those, you can replace the rejection handler with a rejection handler of your own. You probably know in Micronaut there is an annotation called add replaces, which you will pass the class that you want to replace. So it's really easy to replace one bean with another one in case the one that you are using is not what you want. Also, many of these security beans can be disabled through configuration. So many of these beans have like a Boolean flag which allows you to disable them. If this diagram is a bit overwhelming, don't worry. We will see how to use Micronaut security. Many users will use Micronaut security without really understanding what's going on in the security filter. But I think it's good to have an overview of what's happening. So we said that when we turn on security, by default, every request was being rejected with a 401. So how do I allow anonymous access to an endpoint? So there are several ways to do that. We have one annotation called add secured, which you can qualify either with roles, which we'll see later, or with some expressions. There is one expression called, which I normally like to use directly, the constant. So the value of the constant is anonymous with parentheses. So if you annotate at a method level an endpoint, this will automatically, when the request goes through the filter, the add secured security rule will let this request through, even if the user is not authenticated. So an anonymous user is a user that is not authenticated, or a user that is authenticated. You can think about it like this is allowed for everyone. The add secured works as a class level. So if you want to basically basically annotate all the methods in a controller as being available for everyone, I personally prefer the annotation at a method level, even if there is some repetition, because if you later refactor the method to another class, if you have it in a controller in a class level, it's easy to leave the annotation there, and maybe you even change the security constraints of the method. So yeah, that's a personal preference, but important bit is both class level or method level are supported. Another cool thing is, and that's why we needed the annotation processor method, is if you don't want to couple your application to Micronaut annotations, we support the JSR 250 annotations. So one of them is the permit all. So JavaX annotation.security.permitAll. So this is exactly the same as the annotation we saw before. So if you annotate a method with add permit all, that's the same as add security is anonymous. So yeah, with this annotation, you will let through anyone in the application. Another way that you can do is you can use an intercept URL map. The support for intercept URL map is turned on by default. So you have here in the top a controller with without any annotation. So by default, this controller will be secured. This controller endpoint will be secured. But here in the bottom, I have in YAML, the intercept URL map takes a list. So this format is it's a bit weird, but it's the YAML format for a list. So it's basically a list of maps. So you define a pattern that you want to match. Regular expressions are allowed. So I could have something like books / asterisk. And then you set the HTTP method that you want to match. And then you can set a list of access. The list of access is also a list because you can have like different roles in a list. So yeah, with this in place, when you go through the filter, this time it will not be the add security rule that lets the request through, but it will be the intercept URL map security rule that will let the request through. I normally, for controllers, methods that I basically control that is in my classes. I use the add security annotation, but the intercept URL map is a feature that is really useful. For example, if you are like serving some static resources in Micronaut, you can serve the static resources. So for example, you can have like a web application which serves images or CSS files or JavaScript files. Imagine you want to serve like a logo, and you want, when someone comes to localhost 8080 /static/logo.png, you want that logo to be displayed even if the user is anonymous. So as we said, when you turn on security, everything is 401 by default. So if you are serving static resources, you may have a configuration similar to the one that I am displaying here. So the logo will be here under source, main resources, public, and then there will be the logo.png file there. So that's what you see, the class path public. So that means that you can have like a folder under the resources named public and put your resources there. And then you can say like the mapping is different. The mapping you want to be static because you like that name. So yeah, for controlling the security access level of static resources, I believe intercept URL map is the way to go. Now I wanted to talk about the basic auth. Basic auth is like the simplest form of authentication. What does it mean? It means you are in a browser or you are in a terminal or you are calling the Micronaut application from mobile phone applications. So you send a request. The server responds 401 unauthorized. And then what you do is you send the request, but this time in the HTTP header authorization. You include the following. You include basic, space, and then you include the username, semicolon, the password, and then you take that string and you encode it as base64. So no, this is not encrypted. This is just encoded as base64. So once this goes to the Micronaut application, we will see that we will attempt to authenticate. We will basically retrieve we will read the token with a token reader from the authorization header. Then we will call a token validator, which there are some token validators in Micronaut, which use one collaborator, which we call authentication provider. We will see how to create one authentication provider now, and we will see how to use some of the out-of-the-box authentication providers that ship with Micronaut. So basically, after the basic auth token validator, we will either have an authentication or not. And then we will, knowing that, we will call we will evaluate the security rules. And if any of those security rules let the user through, then we will return a 200 OK. So in the security filter picture, for the basic authentication, there are by default a couple of bins, which actually you can disable if you don't want basic authentication to be in the system. One, there is a token reader, which is called basic auth token reader, and this does what you expect. Basically reads the token from the authorization header and removes the basic prefix, and I believe returns I don't know if it decodes the token there or the base64 decode happens in the basic auth token validation. I believe it happens in the basic auth token validator. So the basic auth token validator, it uses the list of authentication providers. So authentication provider is a type of bean that will be present in the Micronaut application context. So it will basically try to authenticate. We'll see there is like a credentials object that will be supplied to the authentication provider. And if the authentication provider is successful, it returns an authentication object. So here I have an example. So in the top, I have a curl command with, if you use the -u, it basically does a basic auth. So I am doing a basic auth against this endpoint. And here I have an authentication provider. With this authentication provider will be used by the basic auth token validator. So first thing you will see here is the class is annotated with a singleton. So what that means is that it will be present in the application context. So it is a bean in the system. It's a bean of type authentication provider. You see here that the method, it has one method which returns a publisher of authentication response, and it takes an authentication request. The authentication request has a username and a password. So the username is actually called identity. And I believe in the second one, there is a typo that should be secret. So basically what I'm doing here is a really naive implementation when I check that the username and the password match what I expected. And if that's the case, I instantiate one object called user details, which implements the interface authentication response. And here I pass the username and a list of roles. So typically, if you need any authorization thing in your application, your authentication will have a username and a list of roles and eventually some additional attributes. But one important attribute is the roles, because that will allow you to play with some annotations such as roles allowed that we will see later. So as you see, this implementation doesn't use any database, doesn't use anything like that. So chances are you want to use the following scenario that we have called the delegating authentication provider. What that means is you don't need to code authentication provider, but instead you need to supply several beans. And if you supply those beans, this bean is automatically turned on. So Micronaut has an annotation named @requires. So you can annotate a bean with @requires and specify that you require other beans to be present in the application context in order for this bean to be loaded. So this is what we are doing here. Unless you don't supply several beans that we will see shortly, this authentication provider is not present. So how does this authentication provider works? This is the authentication provider that you are used to. So it's a typical authentication provider that when someone enters a username and password, the first thing you need to do is you need to go to the database. You need to fetch a user. If the user is found, then what you do is you take the password that the user supplied and you encode it. And then you check that this password that you just encoded matches the encoded password that you are saving in the database. If those match, then you go ahead and you fetch the roles for that particular user. And if everything goes well, so you have verified that the password matches, you have verified that a user with that particular username exists in the database, and you have retrieved the roles, then you are able to get an authentication. So I have a couple of slides here of the required beans. In these slides are implemented in Groovy. So Micronaut is you can write Micronaut applications either in Java, Groovy, and Kotlin. Most of the code that I have here in the slides is in Java, but for some of the since Groovy is much succinct, has less verbosity, I have picked Groovy for a couple of beans. I hope that I don't think anyone will have any problem to follow through. So the first thing that you need to do is you need to provide a bean of type user fetcher. So you create a bin, you annotate it with Java X inject.singleton. We implement the user fetcher interface here. I am doing some constructor injection. So I am injecting another service called user.gorm service, doesn't matter. So the only thing that important is that I am overriding the find by username. And this is like I am fetching a user from the database. And if the user is not null, so it's present, then I am returning the user. I am returning actually a class called user state. So the find by username of user.gorm service returns a user state here, so I don't need to do anything special. So first step is in order to use a delegating authentication provider, is you create a bin of type user fetcher. This bin is responsible of fetching the user from the persistent that you are using. Then I have here another bin called I name it authorities fetcher service, but the important thing is not the name, the important thing is the type. So it's of type authorities fetcher, and authorities fetcher force you to implement one method, which is find authorities by username. So this will be given my username. If I give you my username is Sergio del Amo, then this user has the role admin and role manager. You return those. And then the last one that you need is an implementation of password encoder. So we don't ship with any password encoding bin, but creating a password encoder bin is really easy. Here, for example, I am using the Spring Security crypto dependency, which is a great dependency with a bunch of password encoders. One of these is the bcrypt password encoder, which is the one that I am using here. So the only method that you need to override to create a password encoder is you create a bin, which implements password encoder, and then you override a method called name matches, where you supply the raw password and the encoded password, and yeah, that's it. You basically check that the both password match, and if that's the case, you consider that the user is authenticated. So 3 bins: user fetcher, password encoder, and authorities fetcher. And with that in place, you have a working delegating authentication provider, which will be used, we will see that, by, for example, the basic auth token validator will use that, and also the login endpoint will use that as well. So another, so we saw the basic authentication, basic auth authentication. Another authentication that you can use is session-based authentication, which is the authentication that we have used for many years in the web application development world. What you will need to turn on, you will need to put a dependency in place called the Micronaut security session dependency. The Micronaut security session dependency has a transitive dependency in Micronaut security. So you see that I don't have here the compile Micronaut security dependency. That's brought transitively by the other one. And then you will need to turn on security, and you will need to turn on security session. So you see there at the bottom in the YAML file, you see that I am doing micronaut.security.session.enable true. So that will turn on the security session supporting Micronaut. That will what that will make is that several bins will be registered in the application context, especially designed to work with security and session-based authentication. If you are using the Micronaut command line interface, which I would recommend you to do, because it's really easy to install, for example, with something like sdkman.io. You can, the command line interface supports the concept of features. So when you are creating an app, you can pass a list of features. One of the features that we have is security session. What that will do is that will put the required security dependencies in the build.gradle file, and I believe it will add also it will modify, I believe, the application.yaml as well. This will be the schema for session-based authentication. So normally you will play a lot with redirection. So by default, you can change some of these redirection values with configuration. So by default, when you try to access a URL for which you don't have access to, you will get a redirect to a configuration parameter which we call unauthorized target URL. The important bit is that you understand the flow. So I try to access something, I am redirected to a page. Typically, there will be a page where you have, I imagine, like a form either to log in or a button to sign up. So if you have like the form to log in, Micronaut has a controller that you can enable. We'll see how to enable that, called login controller, which exposes a method, exposes an endpoint named /login, which actually you can configure the path. So if you are like, I don't know, if, for example, myself that I live in Spain, instead of having the login controller path be login and I want something in Spanish like entrar, I can change that. So the path of these endpoints is completely configurable. So once you hit the endpoint, you will try to authenticate against authentication providers. So for example, the ones that we saw. And here the changes happen. So if you are using session-based authentication, if you manage to authenticate a user, what you will do is you will create in the session for the session ID, you will save the authentication as an attribute of the session, and you will return a cookie with the session ID. So browsers, as you probably know, when you are using a web applications, they send cookies back and forth without you doing anything. So this is really easy to implement in the client side because, browsers do that. Browser sends cookies. So the next time the user tries to access the books endpoint, the cookie with the session ID will be sent. Micronaut will try to see if it has a session with that particular ID. If it has, it will basically retrieve the authenticated user from the session, and it will consider at that point that the user is authenticated, and then it will perform the necessary security rule evaluation and continue the flow. So this is nothing different that where you are used to if you have used session-based authentication with other frameworks such as Grails or anything of that kind of Spring Boot. So it's the same concept. You basically create a session ID and you set a cookie with the session ID, and in that particular session, the authentication can be retrieved. During the session based authentication, I mentioned a couple of endpoints, a couple of controllers that you can turn on. One of the controllers that you can turn on is the login controller. So when you turn on the login controller, in order to do that, you basically have to configure, you see there in the top, in application.yaml, you have to set up micronaut.security.endpoints.login.enable true. And if you do that, you will have an endpoint which will be /login, which will take either a form URL encoded payload or a JSON payload with a username and a password, and it will try to authenticate those credentials against the list of authentication providers that you have registered in the system. If you manage to authenticate the user with those credentials against any of those authentication providers, then you will you will have an authentication object which you will fetch to a login handler, which is another bean. And that login handler can do things like, for example, when you are using session-based authentication, the login handler will set the authentication in the session and cause a redirect. If you are using something like JWT that we will see later, you will create like a JSON object and send that back to the browser, or you can, even if you are using JWT, you may choose to create a cookie with the JWT in a cookie. So, and if any of those it's not enough for you, you can create your own login handler. So basically, there is both a login handler and which has two methods, if I recall correctly. One for like success login and one that is like for failure login. So yeah, you can do many things like redirects, like responding something, doing any logic that you need to do when a user logs in. There is another controller that you can enable, which is the logout controller. You enable the logout controller by the same way. You set micronaut.security.endpoints.logout.enable true. The logout controller doesn't take any parameters, but what it will do is it will retrieve the authenticated user. It will do that the same way we are able to create the authentication user when we go through the security filter. So we will see now how to retrieve the user in a controller method. I mean the authenticated user in a controller method. So once it goes in the controller, it will use the authenticated user and a logout handler. Again, logout handler is a bin that you can configure, and you will take that object and logout. We have a couple of logout handler implementations. For example, for session-based authentication, if I recall, we remove the user from the session and trigger a redirect. For JWT, I believe we don't do anything because there's not much to do. For you may choose to invalidate a token if you can invalidate a token. If you are using the auth2 support, the logout handler can trigger a call to the end session endpoint in the authorization server. So there are a couple of flows that you may choose to go through, but as always, we have tried to leave things pretty open so that you can choose the configuration that you want by providing your own bin. So authentication. We saw before how could you annotate a controller to permit all users to access that controller, permit authenticated users or anonymous users. Now we are going to see how to annotate a controller to allow access to only authenticated users. So easiest way is probably to use the @secured annotation and use the security rule .isAuthenticated constant, which is a string with value isAuthenticated parameters, isAuthenticated parentheses. That will lock this controller endpoint, and this will be only accessible for authenticated users. Another way to do this thing is to use it as a class level. You may need to restrict the access only to users with a particular role. You can do that as well with a list of roles. We support as well the roles allowed annotation, which lets you do the same thing. This is a JSR 250 annotation, so you don't couple your application with Micronaut annotations. You can retrieve your current user in a controller. We support the Java .security.principal annotation. So you can, if you have an endpoint, for example, that is accessible for authenticated users and anonymous users, you can flag that parameter with @nullable. And if the user is authenticated, my code will bind the authenticated user to that parameter. If it's not, it will be null. So if you see there, the second line checks that principal is not null and calls principal.getName and returns a different list of books. If the endpoint is only for authenticated users. You will not need to add the @nullable annotation. You can, if you need more information than the username, you can basically use authentication as a method parameter as well. And authentication has the name, but also has get attributes, which returns like a map of attributes. So if you were using something like JWT authentication, you may have access here to all the claims of the JOT token that was used to authenticate. If you want to retrieve the authenticated user, even if I am showing this in a controller, if you want to retrieve the authenticated user, for example, from a bin that is a use case or a service, depending on how you name it, you can inject a bin named security service, which has several utility methods. One of those methods is get authentication. So yeah, if you need to retrieve the authenticated user in an artifact that is not a controller, check out the security service. We have support for LDAP authentication. We have actually an awesome support for LDAP authentication. We support more than one LDAP server. Here I have on the right an example of the configuration for one LDAP server. You see there micro.security.ldap.default. Default will be the name of this LDAP server, but you can have like several of these configuration. Each one will get its own settings, so you can have completely different settings. You can enable one and disable the other one. So really powerful if you have several LDAP servers that you need to use as authentication providers. In order, you will need to add another dependency. So you will need the Micronaut security LDAP dependency in your, if you are using Gradle, in your build.gradle file. But yeah, really powerful, really straightforward to use. We have one guide, I will mention the guides later, but we have one guide about LDAP. Let's talk about the JWT fast because I'm running out of time. So we have support for JWT, several things. You need to add the Micronaut security JWT dependency. You need to turn Micronaut security.token.jwt enable true. Or if you are using the command line interface, you can go with feature security JWT, which this will be the typical flow where you supply a JOT token as an authorization header with var prefix. So if you try to access the books endpoint, you will get a 401. Then you call the login endpoint with the username and password as JSON credentials. You authenticate against the authentication providers. You generate a JWT, sign it, and optionally encrypt it. We have, you can have some bins to have the signature and encryption configurations. So you sign the token and you return a JSON payload, which by default contains an access token, which is a JOT token. You have a refresh token, which is a JOT token. By default, access token expires, I believe, in 1 hour, and refresh token never expires. You can change the expiration of those with configurations. And for convenience, we include a couple of other we include the username and the roles and the expires number of seconds in the JSON payload. But the important bit is that we include 2 JOT tokens, 1 access token and 1 refresh token. Once the access token expires, you can use the refresh token to get a new access token. So the next time you access the books endpoint, you will supply the access token in the value of the authorization HTTP header, prefix with var. And again, we will validate the signatures and we will validate the claims. We'll talk about those later. If both signature and claims validation pass, we will create an authentication and then run through the evaluation of the security rules. here I have the same flow, but instead of sending, you can configure so that the login endpoint, instead of sending like a JSON payload, it can send in the, it can basically create a cookie with the access token as a value. And then since browser sends the cookie all the time, it will be transparent for you. You will receive the access token in a cookie. You will read the access token from the cookie and do the same JOT signature verification and claims verification. So both are documented. I believe we have 2 guides. So for each of those flows, you should be able to set this up with no problem. In order to sign a JOT token, you will need to create a generation configuration. We have a couple of, so you can either create the beans or use some of the out of the box. So for example, if you want to create like a, with a secret, it's important here that this thing is named generator. So this will create a bean which will allow you to sign and also verify signatures with this particular secret. There are like many possibilities that we have to either use RSA or elliptic curve signatures. So please check it out. This is like the simplest example using just a secret, but as you can see, this out of the box, this is a simple setup. You can have like, of course, you will not have this like the secret in committed to your source version control. You can have this like use like an environment variable or something like that. So really easy to set up a JOT generator. I have here a couple of slides. This is in the documentation, so I'm not gonna go a lot through this. So basically, you can create several kinds of beans to and use the @name annotation to register them as JOT generators, and then you can have like multiple signature verifiers. So yeah, create, check the docs, and if you have any problems, please let us know. You should be able to have a lot of options. So once you have verified the signature, we have one kind of bean called the generic JWT claims validator, which right now there are two beans. One is the expiration JWT claims validator, and another is the subject not null, which the one will check that the there is one claim for the expiration. We will check that the JOT token is not expired, and the other one will check that the subject claim is not null. You can disable these verifiers if they are not what you are looking for. You can create your own. So really easy to basically, if you just need a custom validator, you just create another bean which implements generic JWT claims validator, and that will be automatically picked up by Micronaut to validate the claims. To refresh an access token, you can turn on another controller, which is the refresh controller. You turn that on by Micronaut security.endpoints.auth.enabled, and that will turn on that controller, and you can send the refresh token with a particular payload, and that will return you a new access token. We have support also for JSON Web Key. So JSON Web Key is a way to represent a cryptographic key. So we actually support as well a JSON Web Key set. So that's basically a set of these JSON Web Keys. We make really easy to expose the, so this typically will be used to expose like a set of public keys as a JSON Web Key format. So we have one controller called the keys controller that you can enable with micronaut.security.endpoints.key.enabled, and you need to provide a bean that implements JW key provider. Here I have an example of one that does that with Groovy. So we are using a library called Nimbus Jose for working with JWTs. So yeah, this is an example of basically inflating one JW key with a string. So this is a multi-line string of Ruby. So yeah, really powerful. You can really easily expose your public keys as JW key format. And it's really powerful because you basically, once you expose the endpoint, you can call it with that. But it's really powerful because if you have another microservice in your federation, we have remote JWKS validation. So if you have one endpoint that is the one that exposes the public keys that should be used by the others in the federation, you can consume those public keys with this configuration. As you see, it's pretty easy. You basically create a signature, a JWKS, you give it a name, and the URL where that particular endpoint is. So this expects a payload of this structure, and if the payload of that structure is received, then it will create the signature configuration necessary. This will refresh it will basically attempt to refresh the keys with a period of time. We have security events as well. So if you are working with an app and you want to receive an event when a user failed to log in or when a user log out or something like that, you can register to these events that we trigger through Micronaut. Registering to such an event is really easy. You implement application event listener. You qualify it with the event that you want to listen. And here I am, for example, listening to the logout event. So yeah, if you need any audit, really powerful. We have some features specifically designed to work with microservices. One of them is token propagation. So imagine you have 4 services and you are using in all of them JOT. You are basically supplying a JOT token in the authorization header. So you are using like this with prefix with bearer. So you don't want to have all your code full of, you don't want to receive the token and pass it through all your code base and then call an HTTP client and create a header and pass the token. So we have one thing that we call token propagation, which will basically include propagate the token that you received in the original request in subsequent requests automatically. So here I'm getting a token in the gateway service. And this service is calling the catalog service and the inventory service and the recommendation service. And it will propagate the token that I originally received automatically. You will need to turn on some configuration options. For example, here I am turning on what we call the token writer. So I'm turning on the token writer so I can write a token in the header. And then you don't want to propagate the token everywhere. So you need to specify, so the service IDs, you have used the Micronaut HTTP client, this name that you put in the add client annotation, that will be the service ID. So you can have like a regular expression to match the services that you want to propagate, or even you can match URLs with a regular expression. So really powerful. It makes really a joy to work with security in Micronaut services because security gets out of the way while still being there. We have been working on Micronaut OAuth 2 security support. This is still on a build snapshot phase, but we'll ship with 101. You can check the docs in, so the project is in github.com/Micronaut projects/Micronaut OAuth 2. We have already documentation there that you can check. You can install this already in your apps. So you will need to run 1.1.0 milestone 2 at least, and then install the build snapshot dependency of this module. You will use this to work with services such as Okta or Auth0 or AWS Cognito or something like Keycloak. So typically with each of these services, you will create an app which will give you a client ID and a client secret. So here I have a screenshot of AWS Cognito, which gives me the client ID and the secret. And you will need to, in your configuration, basically supply that. Here I'm using like configuration interpolation with environment variables. So this will be like, for example, for AWS Cognito, the required configuration, where you basically tell, we are using one feature of OAuth 2, we are using the well-known OpenID configuration to basically retrieve the configuration from the authorization server and configure accordingly the Micronaut application. So we basically, you almost don't need to do anything. Depending on the authentication provider, you will need to do some extra steps, but for most of them, it will be completely transparent to you. You basically set up the client secret, the client ID, and the issuer, and we will set up everything for you. This will be, for example, the configuration that you need to use authorization code flow. You see here that I am enable cookie and JWT, although it's not required that an OpenID provider responds your tokens. That's typically the case. So chances are that if you are using the OAuth 2 support, you will use the JWT support as well. So this is one flow that we currently support, and this will be the authorization code flow. So you will have a Micronaut app. The nice thing of using an authorization provider is that you don't need to implement like user registration or login or password resets or multi-factor authentication. That's taken care by the authorization server. So the way we do this thing is once you go, an authenticated user goes to a URL that is secured in a Micronaut app, we redirect the user to the authorization server, and we basically ask for the code flow, and we supply a scope of OpenID. And the authorization server then typically displays a login page to the user. The user will log in there. It gets authenticated, and the authorization server redirects us with an authorization code. And what we do is we exchange that authorization code for an access token and an ID token. We validate the ID token. So we do some ID token claims validation as the OpenID specification states, or you should be able to use the introspection endpoint to validate the token if you want to do an extra trip to the authentication server. And once the ID token is valid, we know that the user is authenticated, and one option is to save the ID token in a cookie and let the cookie be sent back and forth and be validated in my Micronaut app. So basically, this is the flow. As a programmer, you don't need to do much, which is really nice. Everything is taken care of by the authorization server, and Micronaut configures itself automatically and gets out of the way. In the logout, we normally will call the authorization server logout endpoint. So when you log out, we, for example, call the authorization endpoint, and then we will remove the cookie. So we will log out locally and also from the authorization server the user. So the next time the user tries to access a secure endpoint, he will need to go through the authorization server login page again. We support as well password grant type. Password grant type is, if you are using OAuth 2, that's probably not the best flow, but it may have some uses. The bad thing is that you are seeing the client credentials, which is not ideal. Even if you don't save them, you are like in a man in the middle. So here I have an example where the user sent us the client credentials as a basic authentication. And what I do is I use the password grant type and send those credentials to the authorization server, and the authorization server automatically sends me the access token and the ID token back. So if for whatever reason, I have seen some use cases, for example, you are using a third-party app that the only authentication way that they can use is basic authentication. So the user will need to enter the credentials there. This will be an option at your disposal. So yeah, we support the password grant type. It's probably not as widely used as authorization code, but it's there. We have several Micronaut guides under guides on Micronaut.io. We have many guides, but we have some of them which deal with security, which explain what I have covered here pretty fast with more detail. Yeah, please check them out. Give us feedback if you find anything that is not there. I am ready for questions. I see one question from Jason Jacobsen regarding Kerberos. We don't have any support for Kerberos, I believe. Yeah.
Sergio, we also had one question from Anton about is the token propagation working only with JWT? He's wondering if he can write his own bean to propagate some custom headers.
Token propagation actually works with custom headers. We use it, for example, so we support multi-tenancy in Micronaut as well. So when you can have like a software as a service, and you can have like one database per customer. And traditionally, you may have a monolith, but if you are like using a microservices architecture and you want to propagate like what's normally referred as tenant ID, you can propagate that too. We are using the same thing, token propagation for tenant ID as well. So yeah, there's nothing. So we are using it for security token, but we are using it for multi-tenancy, and I think you shouldn't have any problem to propagate your own token. Is there native support for Keycloak? Yeah. Does it just work like the Okta support? Yes, it does, Jason. So I have on my to-do list to write the guide for Keycloak, but it's really similar to Okta, almost identical. So I have verified that our implementation works with Okta, with Auth0, Keycloak, and AWS Cognito. And I think that any OpenID Connect provider which complies with the specification, it will work with us, because fortunately there is a specification and a set of defined endpoints and flows that we can code against.
And then we have one more. Is there an X509 certificate authenticator available, or do you have to build one on your own? And
There is not. There is not. I believe there is not. I think you need to write that on your own. So yeah, that will be a great PR. So yeah.
So we can hang around here for a few more minutes in case any more questions come through. But we want to thank everyone for joining us today. We will be sending out a recording of today's webinar along with the slide deck. And we do have a Micronaut security workshop coming up next month. So whenever we send you all the information or all the recording from today's webinar, we'll include the information to sign up for the Micronaut security workshop. So thank you again. And like I said, we'll hang out here in case there's a few more questions, but we want to be cautious of people's time. So if you have to leave, feel free. And thanks again for joining us.